Let's talk about integrals with exponential and logarithmic functions. If u is a function of x, then the integral of e to the u times u prime dx is equal to the integral of e to the u du, which is equal to e to the u plus c. In particular, the integral of e to the power of x dx is equal to e to the x plus c. So example 1 wants us to evaluate the integral of -4 times e to the x dx, and using integral properties, we can rewrite that as the -4 times the integral of e to the x dx, and using this here, we can just rewrite this as -4 e to the x plus c, and that is our answer there. Example 2 says evaluate the integral of x cubed times e to the power of 3x to the 4th power. So we want to use u substitution, and so I'm going to make my u value 3x to the 4th power, and I knew to do that because once we take the derivative, we get 12x cubed dx, and we have an x cubed there. So what I need to do is I need to divide both sides by 12 here, and we get that du over 12 is equal to x cubed dx. And I have an x cubed here, and I have the dx here, so I'm going to be able to substitute that with du over 12. So let's go ahead and make some substitutions. That integral x cubed e to the 3x to the 4th power dx, we will be able to rewrite that as e to the u power, since our u is 3x to the 4th, times du over 12. And I'm just going to make that look a little bit nicer. I'm going to take out the 1/12 times the integral of eu du. And we know that that is equal to 1/12 e to the power of 3x to the 4th power plus our integration constant. Example 3 says evaluate the integral of x cubed over e to the 4x to the 4th dx. I'm going to rewrite this really quickly. I'm going to rewrite this as x cubed times e to the power of -4x to the 4th power dx. And so that will make it a little bit clearer for what we want to make our u value, which is going to be -4x to the 4th power. Then du will equal -16x cubed dx. If I divide both sides by -16, we get that du over -16 equals x cubed dx. And notice x cubed dx is right here, so we can just make that substitution. So our integral now will be equal to e to the u times, and then I can just substitute in the du over -16, and I'll rewrite that as -1/16 times the integral of e to the power of u du. And then that will equal -1/16 times e to the -4x to the 4th power plus c. And notice here that I just substituted the u value back in for the exponent right there. Example 4 says, as the housing market emerges from the collapse of 2008, suppose the rate of change of the value of a house that costs $200,000 in 2011 can be modeled by the function dv dt equals 15.4 times e to the power of 0.077t, where v is the market value of the home in thousands of dollars and t is the time in years since 2011. Part A says find the function that expresses the value of v in terms of t. So we want to find our function v, which is going to be the integral of our dv dt function, which is 15.4 e to the 0.77 I missed a 0, sorry, 0.077t dt. So we're going to use u substitution. I'm going to make u equal to 0.077t, and then if we take the derivative of that, we'll just be left with 0.077 and then dt. And I'm going to divide both sides by 0.077. So we get that dt is equal to du over 0.077. So we can rewrite this integral. I'm going to factor out or bring out the 15.4, and then e to the power of u, and then dt we're going to replace with du over 0.077, and I'm going to bring that out, the 0.077, so we have the integral of e to the u du, which will equal 15.4 over 0.077 e to the 0.077t plus our constant of integration. So we're almost done with part A. What we've done is we found the function. However, we still have our constant c that we need to figure out. But we know we have the information that in 2011, the cost of a house was $200,000. And so 2011 is 3 years after 2008. So we know that, I'll write it up here, that v of 3 is equal to, v is in thousands of dollars. So v of 3 is going to equal 200. So how are we going to use that information? Let me erase some of this stuff. Okay, so what we need to do is we need to set, first we need to plug in 3 into the function. And once we've plugged in 3, that whole thing is going to equal 200. And now this will allow us to solve for c. So I'm going to go ahead and throw that into my calculator. I made a slight mistake here, and hopefully you caught it as I was talking about it. The input is supposed to represent, the t-value is supposed to represent the time in years since 2011. I initially interpreted it as t was being the number of years since 2008. And so what we need to do is this, I put 3 here, this should actually be v of 0, which makes our life a lot easier. So it's still going to be equal to 200, but I plugged this thing into my calculator and it turns out that that's equal to 200. So let's rewrite this. So we have 200 e to the, if we multiply 0.077 times 0, that's just going to be 0 plus c, and then we still have that v of 0 is equal to 200. So e to the 0 power, this thing is going to be 1. So we have 200 times 1 plus c equals 200. And we get 200 plus c equals 200. And then we get c equals 0. So our final function, v of t, is going to equal, again, this thing is equal to 200. So 200 e to the power of 0.077 t, and then we found that our constant of integration was 0, so we can just leave it off like that. So that was all for part A. I'm gonna see if I can make some room for part B. This was part A. For part B, it says find the predicted value in 2021 after 10 years. So we basically want to evaluate v of 10. And so that's going to equal 200 e to the 0.077 times 10 power. And if you throw that into your calculator, you get that this is about 431.95. So what does that tell us? So we can interpret this to be thus in 2021, the predicted value of the home is, remember this is in thousands of dollars, so $431,950. So that is our conclusion for part B.